Hello friends, in this session we are going to discuss some properties of inequalities and tips on their usage. So let's first look at this property where we are doing addition and subtraction on each side of an inequality. So let's take an inequality where we say A is greater than B. So this is an inequality. Now if we do some addition on both sides of this inequality, say A plus C is what is added to both sides of the inequality, then the inequality still holds, which would mean A plus C will be greater than B plus C. Right? So now in this case, do we have any specification or any limitation on C? No, it could be anything. It could be a positive number, it could be a negative number, it could be a constant, it could be a variable. So whatever, if we do any addition on the left hand side of the inequality and we do the same addition on the right hand side of the inequality holds. So which would mean A plus B is still greater than B plus C. Now same is the case for subtraction. So if instead of addition we perform a subtraction from both sides of the inequality, which would mean we get A minus C on the left hand side and B minus C on the right hand side, the inequality still holds and A minus C in this example will still be greater than B minus C, irrespective of whether C is a constant, variable, whether it's a positive or negative number. So this still holds. So this is one property of the inequality where it says that addition and subtraction on either side, on each side of the inequality will retain the inequality. Inequality holds. Now let's come to multiplication on each side of inequality. Now we continue with the inequality A is greater than B. Now let's take C as a number which is to be multiplied. On each side of the inequality. So we get on the left hand side we get AC, on the right hand side we get BC. So now can we say that AC will always be greater than BC? No. This will be true only if C is greater than 0. If C is positive, then AC will be greater than BC. The inequality will hold if we are multiplying C with both the sides of the inequality, only if the number which is being multiplied is positive. If C is negative, then AC will become less than BC. So now this inequality reverses the sign. So the inequality reverses if it is multiplied with a negative number on both the sides. So let's take an example. Now supposing A is 2 and B is 1. Now 2 is definitely greater than 1. Now if we multiply this, let's take C to be 5. If we multiply this with 5 on both the sides, we get 10 on the left hand side, 5 on the right hand side. So 10 is still greater than 5. But if C is minus 2, now AC will become minus 4 and BC will become minus 2. Now minus 4 is less than minus 2. So the inequality reverses. So this is very important, that the inequality holds only if the number being multiplied is positive. If it is negative, it reverses. Holds only if C is greater than 0. Now if we come to division on each side of the inequality, it again, division also behaves the same way as multiplication. We know that. from our previous classes that division behaves similar to multiplication. So supposing A is greater than B. Now it is divided by C on both sides of the inequality. So we get A by C on the left hand side and B by C on the right hand side. Now A by C will be greater than B by C. So we'll say it holds only if C is positive. C is greater than 0 means C is positive. If C is negative, then A by C will become less than B by C. So it reverses, the inequality reverses if C is less than 0 or C is negative. We can again see that with the help of an example. Supposing A is 4 and B is 5. Sorry, B is 3. A is greater than B. So A is 4 and B is 3. Now we divide this. Let's take again C to be 5. So A by C in this case would become 4 by 5 and B by C is 3 by 5. So A by C is greater than B by C. Now if instead of this we take C to be minus 2, it becomes A by C becomes minus 2 and B by C becomes minus 3 by 2. So minus 2 is now less than minus 3 by 2. So this reverses when C is negative. So in case of addition and subtraction, the equality always holds if we are adding or subtracting the same number or variable from each side of the inequality. But for multiplication and division, there is a condition on C, on the number or variable which we are multiplying or dividing on each side of the inequality. So this inequality will hold in case of division and multiplication only if the number which is divided or multiplied is positive. The inequality reverses if it is negative. Now we are going to see how we are going to use these properties. Where do we use them and how is it important? Now, supposing, as we said, that in case of division and multiplication, it changes sign. So, supposing we are given something of the type that A by B is greater than C by D. Now, here we cannot do a cross multiplication will result in AD greater than BC. This cannot be done if any of these means ABCD are negative. So we cannot do this kind of a cross multiplication for solving it till the time we are sure that everything is positive. Why? Because cross multiplication is effectively doing a multiplication on both sides. Now what we are doing is we are multiplying both the sides with BD. So by multiplying A by B with BD we get AD, and by multiplying C by D with BD we get BC. Now if we are not sure that the number that we are multiplying this with, which is BD, or that may be a variable, if we are not sure whether it is a positive thing or a negative thing, we cannot do this cross multiplication retaining the inequality. So this is important, and this is where we say that while we are solving the inequalities, it becomes crucial to use this property and then see what action is to be performed. Now let's see with the help of an example. Now supposing we have to solve the inequality x minus 4 by x plus 2 is less than equal to 2. Now one way, if instead of x, if we simply had something like 3 by 2 and we want to compare whether this is less than equal to 2 or not, what we'll do? We'll simply do a cross multiplication and we'll say since 3 is lesser than 4, so 3 by 2 is smaller than 2. So we get the result. But in this case, can we do cross multiplication? No. Because if we do that, if we do this to solve it, this implies that x plus 2 has to be greater than 0. So this is a limitation. If this is not given in the question that x plus 2 is always greater than 2, we cannot use this. So instead of this, what is it that we are going to use? We are going to say x minus 4 by x plus 2 minus 2 is less than equal to 0. Now this is where we are saying holds in case of inequality, holds in case of subtraction. Now instead of 2, in place of 2, even if we had some variable, say for example x plus 3, we could have still performed that same thing because inequality always holds in case of addition and subtraction. So we could perform this to solve it. But we cannot do this cross multiplication because we are not sure of the nature of x plus 2. X could lie in that range of, say it is less than minus 2. So x plus 2 becomes negative and we cannot be sure whether this inequality will hold. So this is an important application where we need to be careful about using these properties to solve the inequalities. Friends, you can visit us at our Cool Smart Learning website and subscribe to our YouTube channel to get updates on the new sessions.